This is our last section. I won't say last video because I think I'm going to be splitting it up into a couple different videos. But last section, and unless I'm combining a whole bunch of sections together here, we were looking at our what are called matrices or a matrix, and how to take these systems of equations that we're looking at and use a computer or a calculator to assist us in this process a little bit more, especially as we start adding more and more and more variables. So what we've been looking at are systems of equations that have two different variables, two unknowns, two things we don't know. And it's possible that there could be more than two things we don't know. You could have a situation, if you're a business, where you have profits, you've got expenses, and you have electricity, and you have healthcare, and you have lots of things that you have to consider and weigh all these different things. And when you have multiple unknowns, you need lots and lots and lots of equations to work with that. And it gets to be very tedious to work through that by hand. So here's a problem. Spring is here, summer's coming, and we want to go on a diet, or this person wants to go on a diet. They need to eat, and this is kind of contrived, but they need to eat exactly 245 calories, 6 grams of protein, and 7 grams of fat for breakfast. That's their diet, whatever crazy new fad diet they're on. Unfortunately, they only have Cheerios, Cinnamon Toast Crunch, and Rice Krispies. So we've got the nutrition information here on the screen. And normally, without this new fad diet, they just dig into the Cinnamon Toast Crunch because they're awesome. And that's true. I can't deny that. But they need to stick to their diet. So they need to work out how much of each of these cereals they should mix and match to get exactly 245 calories, exactly 6 grams of protein, and exactly 7 grams of fat. So they're not purists. They have no problem combining some cereals together and making a fun breakfast. To work with this, we do need to try and write some equations. So we've got 3 different variables, really. We've got the Cheerios, the Cinnamon Toast Crunch, and the Rice Krispies. Those are 3 different variables. We can vary how much of each one that we want to have. We just need to have all the calories add up to 245, all the protein add up to 6, and all the fat add up to 7. Okay, so there I've got that 245, 6, and 7 there for the calories and the protein and fat. So this would be an example of some equations you could write. If C is the Cheerios, T is the Cinnamon Toast Crunch, and R is the Rice Krispies, we could say that we would have 120 calories of Cheerios, 120 times every serving of Cheerios, 130 calories per serving of French toast, 105 calories per serving of Rice Krispies, and whatever decimal or fraction or whole number of those cereals that I have, they need to all add up to 245. So the way this equation was created was basically looking back at this table and saying, well, it's 120 for the C, 130 for the T, 105 for the Rice Krispies. The R equals 245. Same thing with the protein and the fat. 4 times C, 3 times T, 1 times R, and whatever decimal or whole number of servings of Cheerios I have, be 4 times that. 3 times that, 1 times the Rice Krispies equals 6 for the protein, 2C, 5T, and 2R equals 7 for the fat. So that's where these came from. Now we've got 3 equations and 3 unknowns, and we need to solve for all 3 of them at the exact same time. So we need to solve these 3 different equations for 3 different variables so that it works for all 3 of them with the exact same numbers. That's a lot. That's a lot to do. That's not just solving 2 equations with 2 unknowns. I mean, if we try and do the addition method, the elimination method, we'd have to change both of these so it equaled, there's a lot to do there. So let's look at what the book would have you do. So this is section 7.2 is this next piece. This is what the book would have you do. Don't write this down. I am not, well, you can if you want. I am not going to ask you to solve a system of 3 equations by hand. So I'm not going to ask you to do that, or 4 equations, or it doesn't matter. Anything above 2 unknowns, 2 equations, I'm not going to ask you to do by hand. But this is how you would do it according to the book. And this is an accurate way of doing it. What they would have you do is just look at the first two equations. We've got these three different equations. These are not the same as the Cinnamon Toast Crunch ones. I've got these three equations, three unknowns, x, y, and z. And what they would have you do is take just the first two equations and just look at the first two. And if we add the first two together, if we use that addition method for the first two, we're able to eliminate the y's. These two worked out well together, plus y, the minus y. The 2y down here didn't. So we ignored the third equation for a little bit. And we added those first two together, and we got a new equation. 3x plus 2z equals 9. We still can't solve this equation here that they called number 4. We still can't solve this because there's two variables in one equation. But we're stuck with that. So then I said, okay, let's look at the second two equations, equation 2 and equation 3. We take the second two, and we add those together. Well, as they sit, none of the variables eliminate, but we could manipulate it a little bit. We could take the second equation here, the first equation, and multiply it by 2. Because if we do that, now we have negative 2y plus 2y. So basically, they're doing the system or by addition. They're solving this using this elimination method lots of times. First, they're using it on the first two equations. Then they're taking the second two equations and they're manipulating it so that it works out. When they add those together, we've got 5x, no y's, negative z equals 2. Again, we can't solve this yet. Then they take equation 4 and equation 5 and say, look, these two new equations I've created both have x and z in them. Let's put those together. So now they took equation 4 and equation 5, and they manipulated those. And so if we multiply the second one by 2, we add those together. Oh, finally you solve for x. But you're not done. You still have to solve for y, and you have to solve for z. We do have one of the variables, though, x equals 1. So then you can substitute that back in to really either of these equations here. They use the first one, and solve for z. But you're still not done, because now you have to solve for y. So we take another equation, that first equation. We know what x is, we know what z is, we can solve for y. So all that work, and the solution was 1, 2, 3. That's doing it by hand. And those equations worked out nicely. There was no fractions that we had to worry about. So the first one worked out well together. So that's what you'd have to do if you did it by hand. I did that, I showed you that, to give you an idea of how much we need to appreciate these calculators and the computer when we learn how to use those programs to solve it for us. And so that's all the work that would need to go into solving 3 equations with 3 unknowns. You can think about how much more difficult it would be if there were 4 equations with 4 unknowns. Okay, so we're not going to go back to our serial question yet. We need to learn something else first, something called reduced row echelon form. Now you'll notice I still haven't talked about a matrix yet, and that was at the beginning. I mentioned these matrices. So a matrix is really how computer programs write these systems of equations. It's not a new way of doing anything. It's really more of a way of writing it down and inputting it into a computer program. So I've got a smaller problem here. This is 2 equations with 2 unknowns. We could do this by hand, and it's almost faster to do this by hand than it is to boot up a computer and plug it into a computer, because you can do it fairly quickly by hand. But we're gonna look at these with a matrix too. So this is what a matrix does. A matrix, or the way you write this in a matrix, is you ignore the variables x and y, and you just write the coefficients. So the 1 for the x, the -1 for the y, the -3 here for the solution, the 5 for the x, the 3 for the y, and the 1 for the solution. Now a matrix, here's our coefficients. 1x, -1y equals -3. 5x, 3y equals 1. So this offset matrix here, so it's not a square, it's a rectangle. The first column, these are both the same variable. The second column, these are both the same variable, and the last column is the solution. The way you're going to see a matrix oftentimes is with some square brackets. So these square brackets show up on either side. So the square brackets are just kind of saying this is the whole system. This is it, top to bottom, this is the whole system. Now, you may or may not, depending on what text you look at, you may or may not see this dashed line here. I like to put the dashed line, partially out of habit, but partially because this kind of shows the equal sign. We've got our x's or y, we've got our variables over here, and then this is the solution over here. So I'll draw that dashed line, but it isn't necessary that you draw it. So that's a matrix. That's it. That's all a matrix is it takes a system of linear equations and it writes it with just the coefficients. What we're going to do is try and get this into what's called reduced row echelon form. I am not going to ask you to repeat that, but it is going to show up in your calculator and it is going to show up on the computer. And so reduced row echelon form is our goal. And this is what it looks like, or here's the concept anyways, is that we want it to be in this form. Right now we have a 1, a -1, a 5, and a 3. So 1x plus -1y equals -3, 5x plus 3y equals 1. What we'd like to have is this matrix here, where we have 1x and 0y equals something. Because what that means is that x equals something. And this says 0x plus 1y equals something. So we have one, basically we've solved it. X is something, y is something, we have the solutions. So we need to have a diagonal here of 1s and everything else be 0. Because that'd be 0y, 0x's, 1x, 1y. So that's our goal. I'm going to shift over to the document camera. We're going to look at this side by side. So I'm going to solve this, this system, and at the same time, I'm going to work with this matrix. So you can see what is going on with this reduced echelon form and how this works. All right, one thing I could do, and this maybe isn't your first instinct to do it, but one thing I could do with this system here is I can multiply the first equation by -5. If I do that, I'd have -5x minus 5y equals 15. If I leave the second equation alone, if I add those two equations together, I would have 0x's, I would have -2y's, and I would have 16. How this looks in the matrix over here, or what we would do with this matrix, is we would say kind of the same thing, is we want this to be a 1. Remember that reduced row echelon form, we had a 1 here and a 1 there, a 0 and a 0. So we want this to be a 1, and we're good there. We want this to be a 0, to be in that reduced row echelon form. Remember, our goal is to have 1, 0 equals something. That's our goal. So I have the 1 already. I just need this to be a 0. And by doing this manipulation that I just did right there, I end up with 0x's here. So if I take -5 times row 1, so -5 times row 1, and I add that to row 2, the result is, let's see, 1 times -5 is -5, plus 5 is 0. -1 times -5 is 5. Oh, I did something wrong here. I'm sorry. -5 times -1 is +5. Plus 2 or plus 3 is 8. That should be an 8y. My mistake. So -1 times -5 is +5. Plus 3 is 8. So there's that 0x plus 8y. And -3 times -5 is 15. Plus 1 is 16. And I'm going to leave that first equation alone. Okay, so we're getting there. We're getting there. We do need to get this to be 0 here. We got the 0 there. That's great. Now we need to get this to be 0 here. So, well, we could do kind of the same thing. Let's make this a 1. We need this to be a 1. We can easily make that into a 1 by dividing both sides by 8. We get that y equals 2 on this system over here. We do the same thing here. If we take 1/8 of row 2, divide it by 8, the first row is the same. Second row becomes 0, 1, and 2. So I've solved for y. 0x's and 1y equals 2. So y equals 2. The only thing I'm missing now is I have to take that and I have to plug it back in so I can get rid of this -1 here, which I'd have to do over here as well on this side. I would have to take that y and plug it back into an equation to figure out the answer. So I'd have to do x minus 2 equals -3. I'd have to solve for x if I were going to work this problem over here. So I'm going to do the same type of thing. Let's get this down a little bit. I'm going to take row 2. I'm going to add it to row 1. So I'm going to take row 2 and add it to row 1. 0 plus 1 is going to give me 1, so that doesn't change. 1 plus -1 would be 0. 2 plus -3 is -1. Leave that one alone. And I've got it. I've got my reduced row echelon form. Remember, that was my goal, was to have that ones in the diagonal there. Looking over here, if I added 2 to both sides, which is kind of what I did here, I added 2 to the -3, I'd have x equals -1. So I found my solutions. 1 is -1 would be x, 2 would be y. And that's what we get over here as well. So that's what the reduced row echelon form is doing, is it's basically doing what we do with our addition method, except using just these matrices and these rows and adding rows and multiplying rows. We're manipulating it in the same way. It just looks different. Now, on the test, on any kind of project, I'm not going to ask you to do reduced row echelon form. I'm not going to ask you to, by hand, get reduced row echelon form. So you won't have to do that process by hand. Again, I'm showing you this so you know what's going on, that it's not magic, that the calculator and the computer are not just doing some random voodoo and it's giving you an answer. It's basically doing what we've been doing with our addition method. And we got our solutions, -1, 2. A big part of using the calculator, and I'm going dangerously over here on time, I'm going to stop my video here, and I'm going to do a second video where we see how to use the calculator and the computer to do a bigger problem like this. So I'm going to stop with this one, and I'll do a second video on the calculator.